Hello, everyone. I'm Frank, and welcome to episode 26 of Learn How to Sudoku, where we take very easy variant Sudoku puzzles and break them down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Six Whisperer Level 1 by Wook, and here are the rules. Normal Sudoku rules apply, which means place the digits 1 through 9 once each in every row, column, and box. Digits along the marked diagonals do not repeat. So that means the digits along this diagonal, so these 9 cells, and the digits along this diagonal, which is these 9 cells, do not repeat. So they do not repeat on the positive diagonal, which is this one here, and the negative diagonal. Six whispers. Adjacent digits along the dark green lines must differ by at least 6. So this is like if you've seen other Learn How Sudoku episodes, this is like the German whisper rule, except that the difference between digits must be at least 6. So for example, if this were a 2, this would have to be an 8 or a 9 only, because you have to have a difference of at least 6 between these 6 whispers lines. So again, it's like a German whisper line, but the difference must be 6. Renband lines. Digits along a purple Renband line must form a set of non-repeating consecutive digits in any order. So for example, if this Renband line, if there was a 1 on this Renband line, you would know that there's also a 2 and a 3 somewhere on this Renband line, because the only set of 3 consecutive digits, which are not repeating, that contains a 1 is 1, 2, and 3, right? 1, 2, and 4 obviously is not consecutive, and anything else would not be consecutive. So that's how Renband lines work. The digits in cells separated by a black dot are in a 2-to-1 ratio. These are called black Kropke dots. And digits in cells separated by the black dot are in a 1-to-2 ratio. So for example, if this were a 4, this would have to be a 2 or an 8 to maintain the 1-to-2 ratio between them. The yellow color does not have any impact on the rules, so they just have a yellow coloring of this 1. And this is Six Whisperer level 1 again. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now I'm going to get started. Let's learn how to Sudoku. Okay, so small tip here. I know I use this a lot, so I'm going to put this up front. This is box 1. This is box 2. This is box 3. This is box 4. This is box 5. This cell's in box 6. This cell's in box 7. This cell's box 8, or this is box 8, and this is box 9. And because we do that, that's convention, so that we can communicate rather easily and quickly in the Sudoku community, because this is Western reading notation, or common Western reading notation, where you read from top to bottom and left to right. I do that a lot because I like saying which box we are breaking things down on. Okay, now on to actual solving. On the 6 whisperer lines. So if you know on German whisper lines, you know that I've said before in other puzzles that basically on German whisper lines you can never have a 5, because 5 is 5 away from 0 or less, which is obviously not a normal Sudoku digit, and 10 or more, which are obviously not digits. The same for the 6 whispers is extended to 4 and 6, because 4 is 6 away from -2 and below, which are obviously not normal Sudoku digits, and 10 or above, which are not digits. And the same thing is with 6. 6 goes down to 0 and below, which is not a normal Sudoku digit, and 12 and above, which are not digits. So for any set of 6 digits that have a 6 whisperer on it, sorry, for any box or row or column that has a 6 whisperer on it, you can only have 6 digits at most on that. And the one that comes to mind that I first see is box 6, which has 6 digits, which are connected to a 6 whisper line. Therefore, the rest of the digits must be 4, 5, and 6, right? Is there any other one? This has 3. This is 4. This is 5, 6. So the other digits must be 4, 5, and 6 on row 7. This is only 5. 1, 2, 3, 4, 5. That's 5. 1, 2, 3, 4, 5, 6. We have 6 in column 5, so the rest of the column is 4, 5, or 6. 1, 2, 3, 4, 5. That's 5. 1, 2, 3, 4, 5, 6. So we have 6 in column 9 also. So this is 4, 5, or 6. This is 4, 5, or 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We have, no, it's 5. 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6 in row 5. So the rest of the row must contain 4, 5, and 6. Let's see, what else are we missing? 2, 3, 4, 5, that's fine. And those are all the ones that I see that must be 4, 5, and 6. Since this is 4, 5, and 6, and it's in a 1 to 2 ratio, it must specifically be 4 or 6. And therefore, it must be in a 1 to 2 ratio with 2 or 8 or 3, right? Any digit that is consecutive with 2 digits, or sorry, that is adjacent to 2 unique digits on this 6 whisperer line, it has to be at least 1, 2, 8, or 9, right? Because 2 can have neighbors of 8 and 9. 1 can have neighbors of 7, 8, or 9. 8 can obviously have neighbors of 1 or 2, and 9 can have neighbors of 1, 2, or 3. So 3 and 7 can be on the 6 whisperer line, but it has to be only next to one unique number, right? 3 can only be next to 9, and 7 can only be next to 1. Therefore, this is next to 2 unique numbers. Also, okay, we can, similar to German whisper lines, you'll always alternate between low digits and high digits on a 6 whisperer line, right? Because 1, 2, and 3 can only be next to 7, 8, or 9, which can only be next to 1, 2, or 3, so it always alternates. So then we can alternate between these cells. So one of these is which one should we do? Let's do this one. This is one set, this has to be the other set, and this is one set. That has to be also the pink set. These two must be orange, and these two, therefore, must be pink, because they're next to an orange. Now, the thing is, for this, we know there's 2 lows and 1 high. Or, sorry, 2 from pink and 1 from orange. You cannot have 2 more from pink and 1 from orange here, because then that would be 4 from pink. But the thing is, the sets are only 1, 2, 3, and 7, 8, 9. So you can only have 3 digits at most in one set on this 6 whisperer line. So therefore, this must be pink. These both have to be orange. and therefore this is pink. We know there's one each here, right? Because you have to have a low and next to a high. So this is one pink and one orange. Well, that means there's 3 pinks in column 9. That means this cannot be pink. So this is orange, which makes this pink. Now we have also here 3 pinks in column 8, which means those rest cannot be pink. So therefore, this has to be orange also, which makes this pink and this orange. Let's see. We know these are the same set. And if they were both pink, that would mean 4 pinks in row 4. So therefore, these cannot be pink. They must be orange, which must be next to a pink. And that must be next to a pink. Therefore, this has to be orange. This has to be pink then. These two have to be different sets, which means we have one of each of pink and orange. That makes 3 pinks in row 5, which means the last digit or the last cell in that row, which is not 4, 5, or 6, must be orange. So this is orange, which makes this pink. Therefore, this is orange, which makes this pink. Therefore, this is orange, and therefore these two are pink. Okay, what else do we know? We have 3 pinks in row 6, which eliminates pink from being on the 6 whisperer line. Therefore, this must be orange, which makes this pink and this orange. Do we have anything else? We have 3 pinks in column 5, which eliminates any pinks from the rest of the column on the 6 whisperer line. Therefore, this must be orange. This has to be pink. We have now 3 pinks in column 4, which eliminates any pinks from any 6 whisperer line. So therefore, this on the same column, so therefore this must be an orange, which makes this pink, which makes this orange, and this pink. So we have all that information. Unfortunately, this one can still be either one. These are both orange. This is next to 2 unique numbers on... Oh, this has to be... This is a Renban. It either contains 4 and 5 here, and then it's with a 3, because we have a 4, 5, 6 triplet in row 7, and this can't be 4, 5, or 6. Or this is 5 and 6, and this is 7. So either way, this is 3 or 7, which has to be next to 1 or 9. Right? Because if this is 3, this has to be 9. If this is 7, this has to be 1. In addition, we know 5 has to be one of these two. So this can never be 5. So this is 4 or 6. This is next to 2 unique digits on the 6 whisperer line. So this is 1, 2, 8, or 9. All the pinks have to be 1, 2, 8, or 9 that see this. So this is 1, 2, 8, or 9, and this is 1, 2, 8, or 9. In addition, this orange sees 2 unique digits, so that must be 1, 2, 8, or 9. And it cannot be the 1, 9, because we know the 1 or 9 corresponding to it has to be, the orange one has to be here. So this has to be now a 3 or 7. That's with the orange, right? Because this one can't be, and this one can't be. So 3 or 7, whether it's orange or pink, must be next to a 1, 9. So therefore, this is the 1, 9 pink. This has to be the 2, 8 pink, right? Because it can't be the 1, 9 or the 3, 7. Therefore, this is a 3, 7 pink. the 3-7 pink must be next to the 1-9 orange. This is also 1, 2, 8, or 9. This has to be a 3-7 orange because we have 1, 9, 2, 8 already for the oranges. This must be 3-7, which is next to the 1-9 pink. Therefore, this can't be 1 or 9. Therefore, this is a 2-8 pink, which means this can't be 2 or 8, which means this is the 1 or 9 pink. So the reason why we know all this is, again, if you have a 3 here, it must be next to a 9. If you have a 7 here, it must be next to a 1. No matter what the orange is, this can never be then the corresponding orange 3 or 7, right? If this is 3, this would also be the same low set. So it could not be 3, it could not be 7, it would have to be 2 in that case. If this is low again, this would have to be 1. If this is high, it's 7, that means this would have to be 8. And this would have to be 9, because this 9 would have to be with a low 3, right? So that's how we differentiate between these. So we know we have 6 digits in box 5, which are on the 6 whisperer line. So this must be a 4, 5, or 6. Let's see. This has to be, well, we don't know. It's 1, 9, or 2, 8. Orange. This pink is next to 2 unique digits on the 6 whisperer line, and it cannot be the 2 or 8. It can't be 3 and 7 because it's next to 2 unique digits. Therefore, this is the 1, 9 pink, and this has to be the 3, 7 pink, which must be next to the 1, 9 orange. This can't be the 1, 9 pink or the 3, 7 pink, so this must be the 2, 8 pink, which means this is the 1, 9 pink. And this we don't know. This is 2, 3, or 8. So if this were high, this would be 8 and this would be 7. If this were low, it still could be 2 or 3. So this could be 2, 3, or 7 here. This is next to at least 2 unique digits on the 6 whisperer line, and it cannot be the 1, 9, so it must be the 2, 8. So the 2, 8 must be next to the 1, 9 and the 2, 8, right? 2 can only be next to 8 or 9. 8 can only be next to 1 or 2. Therefore, we know this has to be the orange 2, 8 and the orange 1, 9, which means this cannot be the orange 2, 8, which means this has to be a 3 now. So therefore, all the oranges we know are low. So the oranges, we're going to recolor those as blue, and the pinks we're going to recolor as red. Therefore, this has to be 8, this has to be 7, this is 7, this is 9, this is 8, 8, 7, 9. This is 8 and 9, which is next to 3. This has to be 1, this is 2, this is 3, that's next to 9. The 7's next to a 1, which means this has to be 9. The 9 has to be next to, this could be 1 or 2. So this is 1 or 2, and this is 1 or 2. Therefore, this must be a 3, because we have a 1, 2, 1, 2 pair in box 4. So this must be, they cannot be 1 or 2. On the 6 whisper line, the lows are only 1, 2, and 3. So this must be a 3. This, if this were a 3, this cannot be a 9. So therefore, this can't be 3, it can't be 1, it must be a 2, which makes this a 3. 3 is only next to 9 on the 6 whisperer line. This cannot be 2 because of this 2, so this is a 1, this is a 2. This has to be an 8. This can be 8 or 9. This can be 8 or 9. This cannot be 7. This has to be a 2. So it could be 8 or 9 here. It could be 8 or 9 here. We're not sure. But this can't be, this is a 9, so therefore this can't be 9. So this is 8, which makes this a 9. This can't be 2 or 3 as a low, so it must be 1, which means this has to be a 2 to make this renban consecutive. The 1 can be next to a 7, 8, or 9, but it can't be 8 or 9. Therefore, there must be a 7. And this must be a 4, 5, or 6. Well, these cannot be 8 or 9 because it's 1, 2. This cannot be 3, so this is 1 or 2. This can't be 2, so in the C's, 2 unique digits on the 6 whisperer line, so this must be a 1, which must be next to 7, 8, or 9. This could be 7 or 9, and this could be 7 or 8. The low here cannot be 1 or 2 because we have a 1, 2, 1, 2 pair in box 3, which eliminates 1 and 2 from the rest of the box. Therefore, this must be 3 and 9. This can't be 9 because of the uniqueness rule on the diagonal. So this must be a 3, and this must be 9. And that's 3 in the corner. We celebrate those. This can't be 1, similarly, because of the unique digits on a diagonal. So this must be 2, which makes this a 1. The rest of the remaining cells in this diagonal must be 4, 5, and 6. Actually, we actually miscounted earlier. I counted 5 here, and there was actually 6. So this is 4, 5, or 6, and these are 4, 5, and 6. This can't be 9, obviously, so this is 1. We have now 6 digits already filled out in column 8. So this has to be 4, 5, or 6. What's the last remaining digit here? This has to be a 7. Because we have a 4, 5, 6 triplet in column 7, so therefore that eliminates 4, 5, and 6. This can no longer be 7, so this is 9. We don't know about this. This can't be 2, so this has to be 1. Let's see. 2 cannot be here. It cannot be any of these cells in box 1, so it must be here. So this is a 2. Where is the 2 in box 8? It cannot be here. It cannot be any of these cells, therefore it must be here. So this is a 2. Which means we have 8 2's now, which means we can figure out the last one. It has to be here. So this is a 2. It needs to be next to 3, 4, 5, and 6, right? It could have had 1, 2, 3, 4, 5 as a renban, because those has to be consecutive with 2, but we cannot have a 1 because we already have a 1 in the rest of box 1. So therefore, we know it has to be 2, 3, 4, 5, and 6. Therefore, this must be 3, 4, 5, 6, which means this has to be 7 or 8 also. This can't be 3 because of the 3 that's already on it, and this can't be 8 because of the 8 that's already on the diagonal. Therefore, this is 7. This has to be 8. This has to be a high, and it has to be from 7, 8, or 9. It cannot be 7, it cannot be 9, so it has to be 8. The remaining cell must be 4, 5, or 6. Now we have a 3, 7 pair in the rest of box 2 because we have a 4, 5, 6 triplet. Therefore, this can't be 7. This must be 3, which makes this a 7. We have the remaining cell that's not filled with anything must be a 1 then. So this has to be a 1. We could figure that out by just normal Sudoku rules. These 3 digits must contain a 7, and therefore it has to be 5, 6, and 7 to be consecutive. So this has to be 5, 6, and 7. That triplet means that you cannot have 5, 6, and 7 in the rest of row 4. So this can't be 5 or 6. So this is 4. We know this is 6 because it's a 1 to 2 ratio with the 3. That means these can't be 6. This can't be, well, we have a 4, 5, 4, 5 pair now in box 3, which eliminates all a 4 and 5 from the rest of the box. Therefore, this is a 6. These can't be 6. Now we have a 3, 4, 5 triplet in box 1, which eliminates 3, 4, and 5 from the rest of the box. Therefore, this can't be 3, 4, or 5. It must be a 6. So that's a 6. This can no longer be 6, and this can't be 6. This can't be 7. What is the remaining digit in box 4? It has to be a 4. So this is 4. This cannot be 4. This cannot be 4. So, and this can't be 6. The remaining digits now are 3 and 7 in the remaining cells for box 8. Because we have a 4, 5, 6 triplet in box 8, or sorry, row 8 already. So 3 and 7 must be the remaining digits. This can't be 3, therefore this is 7, which makes this a 3. We have a multiple 8s. So where is the last 8? It has to be here. Which means to be consecutive here, it has to be specifically 5, 6, 7, 8. 4 can never be consecutive with 7 or 8 with 4 digits. Specifically with 8, right? 4, 5, you always have to have some space in between if you had a 4 with an 8. So therefore, this is 5. This has to be 6. This can't be 5 or 6 because of the uniqueness rule on the diagonal. So that makes this a 4, which makes this 5. This can't be 4, so this is a 5. These cannot be 5. And this can't be 5. Again, this has to be 5, 6, and 7. So this can't be 4. This can't be 6 anymore because of the 5, 6 pair in row 7. So therefore, this is a 4. Which eliminates 4 from the rest of the cells in the diagonal. Therefore, that's a 5. This can't be 4 or 5 because of that 5 on the diagonal, so this must be a 6. This can't be 4 or 6, therefore this is a 5. This can't be 4 or 5, therefore this is a 6. This can't be 4 or 6, so therefore it's a 5. The last remaining cell in box 7 is a 4. This is just now normal Sudoku. This can't be 5 or 7, so this is 6, which makes this a 5, which makes that a 7. This can't be 3 or 5, so this is 4. This can't be 5, so this is 3. And what's left? This can't be 6, so this is 4, which makes this a 6, which makes that a 4. This can't be 4. This can't be 6. Therefore, this must be 5. That makes that a 6. This is a 5. And this can't be 5 or 6. So this must be a 4. And that's how you solve these. I've actually never run into the 6 whisper rule set. We've actually run into, obviously, there's Dutch whisper, which is the difference between cells must be 4. I've also run into the 3 set, and then not really a 2 set or a 1 set, but 1 set it's just basically anything. And we've run into a 7 set before, 7 whisper, but never a 6 whisper. So this is my first time. Anyways, I hope you enjoyed learning how to Sudoku, and I'll see you next time on Frank Puzzles. Take care.